Hi, everybody. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on this special edition of the Climate Confident Podcast today is Thomas. Thomas is from Siemens. Siemens are sponsoring this episode. Thomas, would you like to introduce yourself?
Hi, Tom. Great to be on this podcast. My name is Thomas Kiessling, CTO of the Smart Infrastructure Division, which is the sustainability decarbonization division of Siemens, I would say. My background is software, IoT systems. I live in California, German national originally, so I spent most of my life in the US and Europe in multiple countries. I'm a serial entrepreneur. Siemens invested in my last startup. Siemens has an amazing vision to become a sustainability-focused technology company, and that attracted me to now having spent the last 3 years helping the leadership team to achieve that vision and to help our customers to decarbonize, to become more sustainable, and to accelerate the energy transition. So that's pretty much my background. PhD in operations research long time ago. And I love building companies and help our customers achieve their company goals, their sustainability goals, their decarbonization goals.
Okay. And Thomas, just for people who might be unaware, when you say infrastructure and Siemens, what aspects of infrastructure do Siemens take care of? Because infrastructure can be anything from building bridges to railroads to et cetera, et cetera, et cetera. Where does Siemens infrastructure slot in there?
Right. Thank you for the question. We call it smart infrastructure, which is even more nebulous. What is this? So good question. When we say infrastructure, it is mostly commercial and industrial infrastructure to provide the power, the energy we are all consuming, to operate the buildings, mostly commercial buildings. We're not so much in residential. The commercial and industrial buildings and factories that we're all using to build our products we all use. We're also active in public infrastructure in the sense of, big renewable plants or, streets and the like. And we provide the tools, the technology to operate those mostly and to make them more sustainable and decarbonize them.
Okay, fantastic. And obviously, Siemens, large company, is going to have a significant footprint of its own in terms of emissions, for example. How do you help Siemens with their own decarbonization mission?
Yeah. So as you would expect, we have a pretty ambitious ambition, sort of targets for the next 5 to 10 to 15 years. And we consider ourselves a leader in setting these targets. So just to give you a few data points here for the discussion, we already halved our CO2 footprint by 2020 in a few years. That all started about 5 to 10 years ago, right? Okay. But there was a massive program that just cut down the obvious sort of carbon-based emissions. But by 2030, we are on track to become net zero. And that's much more difficult. I'll give you a few examples now in this podcast. Mm-hmm. But that's a mouthful. That's very ambitious. And that includes our factories. It includes our fleets of vehicles we're using to provide service to our customers. And we will achieve that by 2030, which I think is, sets a signal, and it's quite ambitious.
And how are you going to achieve it? Is it, will you be buying massive amounts of offsets? Will you be switching to renewables? What are the plans and the strategies for getting there?
Yeah. No, so Siemens is a big industrial conglomerate. We have many different domains, and decarbonization really goes domain by domain. And then you add it all up, right? And you become, net zero. So I just want to give you a few examples. So let's talk about products. We create electrical products. So anything from fuses to switches to actuators and the like, core electrical products. Now, obviously, the footprint here, the eco footprint, is the ingredients, the materials you use to create that switch, for example. So we have committed on as what we call robust eco design, which is looking at all the products we use to create that end product we sell to a commercial building operator, for example, when it comes to the actuators, sensors, and the like. And so that end-to-end footprint, everything from the raw materials all the way to recycling a switch, for example, that constitutes the full carbon footprint. That's the way how we should calculate it. Okay. So we commit on, we're now at a rate of something like a quarter, so 26% of our products are already following the robust eco design and thus are decarbonized, but we will achieve 100% of that eco design standards for all the relevant Siemens product families by 2030. Again, pretty ambitious target. So that's just one example. That's one domain. A very different domain now is factories, our own factories, and their carbon footprint. And just to give you a few examples, we have several factories that are sustainability lighthouses, as per the World Economic Forum, and we're very proud to have achieved that. So we have that designation. For example, one of our factories, Siemens Electronics factory in Chengdu in China, one of our lighthouse factories, I would say, we did cut total greenhouse gases there by 93% in absolute terms since 2019, which is a lot. And at the same time, we increased the output by 90% or whatever the number is. So, if you look at this, if you look at the factory, in a holistic way, end to end, you're able to get to net zero in the kind of factories we're running. It's a little harder if you're in the chemical process industry and you need, heat intensive processes to create chemical products, for example. Sure. That's a little harder, right? The kind of factories that Siemens is running, well, we're creating products, electrical products, charging stations, right? Mm-hmm. Switchgear and the like. And so, if you apply a holistic approach to get to a max percentage of renewable input and production of the energy you're using, if you follow very stringent eco design standards with all, the example I just gave, right? The products that are actually coming out of the factory, right? And if you use electric vehicles, both on the truck and on the service vehicle side for everything that goes out and goes into that factory, if you do all that in a very systematic way, if you then reduce the energy consumption of this factory by 30 to 40%, which is totally doable in the typical settings we're in, you put this all together and you can actually achieve net zero. So that's another example, right? And there is, I can give you more examples of, all the different areas of what Siemens does, but you put this all together and, we will be able to achieve, net zero by 2030.
Okay. And when you talk about the eco-design principles for your products, that's not just, I'm guessing, correct me if I'm wrong, that's not just for the manufacture of the devices, but I'm assuming that also applies to their utilization by your end customers.
That's correct. And that's the famous Scope 3, carbon emissions, which is, just to remind everybody on this call, right? Scope 1 is what you actually emit while you're producing something or while you're operating a building, right? So that's the sort of the carbon that actually is emitted from the building during operations. Scope 2 is, take all the ingredients to produce it. So, for example, the energy you use in the building, does it come from renewables? And then Scope 3 is all the downstream. What is the knock-on effects of your product that are doing carbon emissions? So it's hard to put all three together, right? That's what we're all working on. That's the kind of metrics and measurement systems we're doing. That's very important.
Okay. And speaking of your customers, are you working with your customers to help them reduce their emissions?
Yeah, I mean that's obviously the core value of what Siemens provides, and there I'd like to mention a report we're doing every year, which I invite everybody to take a look at. We call this the Infrastructure Transition Monitor, and so the last version that we published there suggests that progress is basically too slow.
Yep.
We would be able to accelerate, all of us, the path to climate change reversal and decarbonization, because the technology, by and large, I know it's a general statement, but by and large, the technology is there to do it.
Right. Yep.
We just need to apply it, invest, and then, deploy, execute these technologies. So the last version of our infrastructure monitor stated that only 44% of organizations expect to meet decarbonization targets by 2030. That's what the organization, our customers, say.
Yeah.
Right? And then only 47% believe that their country has an effective decarbonization strategy. So, well, decarbonization strategy means regulatory environment, investment environment, and the like. It doesn't mean the technology is lacking.
Sure.
It's got to, you got to apply that technology. So that's, I think just one data point that I'd like to, sort of state here. Now, just to give you a few customer examples, which I personally find really exciting,
Right.
when it comes to, how we help our customers decarbonize. Buildings, represent about 40%, a little less, but about 40% of total human carbon emissions around the world. It's the largest. The other four are industry, transport, agriculture, the energy system. Right. So that's like these five. The fifth one, is buildings, and buildings is the biggest one. Right. So building decarbonization has two aspects. There is embedded carbon, so all the materials you use to construct the building, and then you run that building during 30 years or whatever the lifetime is. And so both constitute 50%. The embedded carbon, roughly a little less than 50%, but roughly 50%. And then the operations of the building, another 50% of the total lifetime output. That operational 50% of the carbon emissions of buildings, that's what Siemens mostly focuses on, helping our customers, so building owners, operators, tenants, to, number one, achieve energy efficiency savings up to 50%. So the average is somewhere between 20 and 30%. But as soon as you put in low-cost digital IoT-based systems to run your cooling and heating systems just a little bit more intelligent than most of the systems are on today, you are saving an average of 20 to 30%, and sometimes going up to 50% and even higher. And we provide the technology, the industrial IoT systems, the digitalization, but also the retrofits to go to a much more modern heat pump system, to do LED retrofits, better access control systems, solar on the roof, storage systems, whatever is necessary to achieve these energy efficiency savings. So, average 30%. If you combine that with 100% renewable input, so solar on the roof or a car canopy if you have parking around it, and you connect this building to the grid in a much more intelligent way, I'm going to talk about this, a little later, you easily decarbonize your building completely and get to net zero. And there's many examples around the world of buildings or fleets of buildings that have already achieved that. So that's a very exciting example. Now, in the grand scheme of things, imagine, you can, all of us, we can do the numbers, right? If 40% of total human CO2 emissions are buildings, and half of that, so 20% of all human emissions, is the operations of buildings around the world, and I reduce that 20% to just a few percent, down from 20 to just a few percent, that's massive. That is real impact for all of us, for humanity. So that's just one example. And many other examples I could give you, right? Because Siemens plays in industry decarbonization, transport decarbonization, e-mobility, building decarbonization. We do less in agriculture, a little bit. We, sort of have a few solutions there as well, but that's not the core of what we're doing. But then one of the really big ones is the energy grid itself. So the energy systems.
Okay.
And that, we have a whole division doing nothing else than, building the software that utilities need to squeeze out more capacity from their networks and to decarbonize their networks, right? To sort of switch on way more renewables in a faster way. And we could sort of deep dive there, Tom, as well, if you like. But I gave the examples of, I just did a deep dive, right, on buildings, how much you can achieve there. And I could tell the same story in e-mobility, and the same story in industry, and the same story in grids and energy networks.
Fantastic. Well, talk to me a little bit more, because you alluded to it, but connecting smart buildings or smart connections to the grid, how does that work?
So that's a initiative that we created quite recently as part of the World Economic Forum, where we felt that the industry actors are looking at this question of how do we getting to 100% renewables and energy grids, often in a isolated way. The utilities, the energy companies, they are scrambling to get in more capacity to achieve the famous doubling or tripling of capacity of electricity networks due to the historic wave of electrification we're all in,
right? Yep.
To decarbonize, right? So they're focusing on that. The regulators of utilities are focusing on getting that capacity out the door. But what we have shown also in a recent research paper, which we discussed widely at the World Economic Forum, is if you now, in a smart way, connect the management, the operations of the building to the grid, so the grid knows how much the building is consuming in the next 15 minutes, 1 hour, next day, and so on, you can squeeze out a lot more capacity from the grid, doing two things. One, you can switch on more renewables in the energy grid faster. And two, you use the buildings as a sink and source of storage,
right,
of energy, because buildings have solar roofs. Many of the industrial buildings have storage systems and the like, which, by the way, also goes for vehicles. Batteries of electric vehicles and trucks and the like, over time, this is all very new and recent, right, will be used to store energy and help the grid to stabilize as well. And we call this GIBS, grid interconnected buildings. And we have shown that the connection of these buildings to the grid, so the grid knows how to control and manage the buildings in some way, has the potential to save billions. We've done that study for the US grid, and to accelerate the rollout of renewables fundamentally. Sounds a little abstract, Tom. I want to just give you one use case,
right.
so our audience sort of gets what I'm talking about. So let's take the example. Let's take an example of how the thermal mass of a building can be used intelligently. So if you know that between 5 p.m. and 7 p.m., you have a peak in the usage of the energy grid, and thus, that's where the bottleneck is, and that's where we have stability problems in the grid, and we simply have, that creates that peak between about 4 to 8 p.m. roughly, and depending on the country, creates a bottleneck, which then leads the grid operators to either curtail the demand or to increase the prices, around that time, charging peak tariffs in order to control that demand. It also leads to delay to switch on more electric vehicle charging stations, more heat pumps and the like, because the grid simply can take it, in particular during that time, because that's the sort of the peak of demand. Now, if you pre-cool or preheat, in particular commercial buildings, in order for that building between 5 and 7 p.m. to use less heating or cooling energy, that will get you a few percent of capacity in the grid. That is a typical use case of using buildings, as in an interconnected way. So the grid actually steers these buildings. You don't have to do this all the time, but in particular in the summer, the worst peaks are happen in the summer between 5 and 7, when the grid has a hard time to cope, with the massive peak, demand. And then so that's an example, right? That's a great example of using buildings, to act in a smart way. That's why we call it smart infrastructure, by the way. To act in a smart way and react to signals from the grid to preheat, pre-cool, or next use case, to use storage systems.
Right.
And many buildings have storage systems, right? Battery storage, to charge up the batteries when the sun is up between 9 a.m. and 3 in the afternoon, and then to discharge that capacity into the peak demand in the afternoon, which again reduces that peak and increases the capacity on the network. So you get the idea, that smart interaction, between supply and demand, between grid interactive buildings and the grid, will allow us to accelerate the rollout of renewables, to decarbonize faster, and to save billions of hardware investment in the grid.
Okay, so the buildings are acting almost like batteries. They become a form of storage themselves, and they're doing demand side management. So they're matching their demand to the supply on the grid is basically. And of course, you mentioned peak pricing, so that if the pricing is going up during peak demand and they're reducing their demand at the same time, then the building's energy costs are dropping as well as their demand. And I think the other aspect of this, which is interesting, is that in times of peak demand, it's not just that the costs go up, but it's also at that time that the energy companies bring on more fossil fuel, typically generation. So at times of high demand, you typically have higher emissions on the grid as well. So if you're reducing your demand at that time, you're making the grid more sustainable. You're dropping your emissions and you're dropping your costs. Would that be a fair summary of it?
Absolutely, yes. Plus, today, the grid operators are curtailing renewables all around the world, in particular during that peak, because in particular the distribution grid, because of that peak demand you were just summarizing, right, can't take the sort of the interconnection of these renewables, which is an adverse effect, which doesn't make sense intuitively at all, right? But if you're able to use certain configurations like storage systems, utility scale storage, to use that renewable production, store it, and then interact with the buildings to optimize the building's demand, we have shown that you can switch on more renewables faster with the existing energy grid,
Sure.
and don't have to wait for expensive upgrades, which are going to take 3 to 5 years.
Sure, because not alone can you reduce your demand at times of peak demand on the grid, but you can also do the opposite, increase your demand when demand is low. And therefore, typically when demand is low, that's when there's more renewables on the grid anyway. So you are again pulling in a higher percentage of low emissions energy, but you're also sending a demand signal for that low emissions energy. So again, it's a win-win. It's a win for the building operator, and it's a win as well for the grid operator, and allows greater penetration of renewables on the grid, right?
That's it. That's exactly it.
Okay.
Yeah. So that was another example, right? Another response to your question: how do we help our customers decarbonize faster? Reap the energy efficiency potential, right? That was the example of helping the grid. Okay.
Yep.
Helping the building, helping the grid, right? Transport would be another example. Industry are more examples.
Okay, fantastic. And what kind of innovations in infrastructure are you seeing, or are you seeing are most promising for shifting the world towards sustainability?
So just a few examples, right? Because again, it just depends on the domain,
Sure.
right? There is no one, there's like dozens of domains we have to watch one by one. Let's talk about transport,
Okay.
right? E-mobility, because that's an example of, sort of high innovative, a lot of innovation intensity. So we're all moving to fast charging, DC charging,
Yep.
Sort of 100, 200, 300, 400 kilowatt charging, which is needed to convert our truck fleets to electric trucks. There you're talking about very large batteries, because these are vehicles that need, much more power compared to a passenger vehicle. Now, these fast charging systems, there's a lot of innovation that's going on there, right?
Sure.
We're able to now, charge a truck in an hour or two with a, fast charger that allows to charge at a rate of 300, 400 kilowatt or higher. But megawatt charging is going to be the next frontier.
Right.
Well, these are massive power electronics devices, because you're pumping megawatts into a truck, which allows you to reduce the charging time then even further, onto closer to what many of us are already experiencing in electric vehicles, where it takes the famous 12, 15, 18 minutes to charge a Tesla at a supercharger.
Yeah.
So we got to do this with a commercial electrical, with a commercial fleet, with the truck fields around the world. And this is one area of innovative activity of many players. Siemens is one provider, right, of these kind of charging stations. One example. Another example is the grid interaction, which we already discussed, right? The kind of use cases, to balance out renewables and, thermal masses of buildings, et cetera. They need real-time control systems, again, which manage the grid in a seamless way, in a real-time controlled way, forecasting the next couple of minutes of what's happening, around everything from weather to production to demand in the buildings and the like. These are, again, massive control systems. A lot of innovation happening there. The buzzwords here are virtual power plants and microgrid controllers and the grid edge and the like. I don't even want to get into the buzzwords here. But that's the systems, the control and digital systems that are managing the interaction between the grid and these new demand areas. Many more. We haven't talked about hydrogen. So we haven't talked about power to X, which is a very interesting area of innovation. There's a lot happening there as well. Industry, let's talk about that. Siemens is pioneering what we used to call digital factories, or sort of autonomous digital factories based on digital twins. So what is this famous digital twin? What is this buzzword, right? Mm-hmm. Which many of you have heard. Well, it is the design of a factory digitally in a model, a simulation model. And that is the blueprint of this factory, which you use to actually build the factory. Well, if that blueprint then is still the same and up to date when you operate the factory, what you would do is you design the next robot in the conveyor belt into the digital twin, and then it gets deployed automatically into the real factory. So that's why at Siemens we call sort of one of our mission statements is combining the real and the digital world, because we might design a factory digitally and then deploy it in the real world, but much faster, in a much more productive way than in the past, where you had lots of media breaks between the various steps of construction. So that increases the productivity. It allows to put up decarbonized net zero factories much faster around the world, which is what we're doing with our own factories, right? We've built several factories like that. But that's the kind of software we provide to our customers to build their decarbonized factories much faster around the world. Once you have the digital twin and you have built one of them, you just reconfigure the same digital twin to build the next factory in another country, because that, you need to comply with different regulations, with different standards, but you can all configure that into your digital twin, and then you build the next factory. So, the rolling out factories now, right? Much faster, much productive way. That's sort of, one of the innovation areas, using simulation and digital twins.
Interesting. And obviously, IoT plays a massive part in digital twins, but we're seeing as well the rise recently in AI. Is that coming in as well to the likes of digital twins and having a significant uptick in effect?
Yes. So, AI is further pushing the efficiency of running assets, and the asset could be a building, a charging station, a factory, a hydrogen electrolyzer. And I just want to give you a couple of examples. This is the, we discussed this recently at the World Economic Forum in sort of groups focused on AI and how AI can help us accelerating decarbonization even faster. So in the case of a building, let's just take that example again. The job of a facility manager today, so the folks that run the building, that make sure that the heating works and that the just the basic operations of the building is just works and is effective. Mm-hmm. That job today is subject to a serious talent crunch. Since COVID, it is very hard to find talent for these kind of jobs. So there is a strong automation push to enable the folks that run buildings, facility managers, to not only run 3 or 4 buildings, but 100 buildings at a time.
Right.
How do you do that? Well, through IoT, automation, digitalization, and AI. So the job of a building manager, and again, this is some real down-to-earth discussion here, right? Would be to come to the office, find a few tickets that some heating system doesn't work, that some access control system doesn't work, that somebody doesn't find their access card. And then you go one by one, doing your job. What about, what if an AI-based Copilot app would tell you that the highest value actions that you can do as a facility manager today, i.e., achieving more and more energy efficiency in your fleet of buildings, are these 5 things. It is to take a look at your solar roofs, because AI found out that you are below benchmark when it comes to the efficiency of how your solar systems run on your roofs, which might be the result of soiling, lack of maintenance, maybe the shading isn't right, maybe an inverter is down, whatever it is. And the AI Copilot gives you the areas you should look at. You look at that, close that ticket, get a repair team up, and you increase the output of your solar roofs in 100 buildings by 3%. That's massive.
Yeah.
As opposed to, I use the same time to take my car, drive to a building, go in a basement, log myself into an HVAC system to understand that some fan handler is broken. Right? So AI can help. And why is that? Because in particular, Gen AI is very effective in analyzing unstructured documents. So if I now run all the information I have on buildings, which is left, right, center, which sits in PDFs and in maybe a BIM document and maybe somewhere on a manual and lots of emails, I just run all this stuff through Gen AI.
Yeah.
Then I can actually define patterns of how I should run my fleet of buildings in a much more effective way. Does that make sense? This is such a nice down-to-earth example.
Yeah.
We often use very sophisticated examples when we talk about Gen AI. But, just the structuring of words, of phrases, of documents, right, of language, this is a language-based model, is super effective to help us doing that. Obviously, we're using AI then for our own call centers, because that enriches the information of a customer who calls in. But that's a generic use case. Everybody is doing that out there. And then just to give you a third, sort of a last one.
Sure.
AI is highly effective in our own products we provide to our customers. The example is a recent launch we did, in a building product. This is our Building X platform that we're rolling out globally now, helping building operators to decarbonize, where we would take in weather information, comfort information, preferences of tenants. So the whole environment of, how do people feel comfortable in a building, at the same time, how far can I go, changing the shading, changing the heating and cooling, changing the humidity, changing any kind of these parameters with the objective to reduce my energy consumption. So again, these are AI models that are training, that are learning the preferences of tenants, working and living in buildings, to squeeze out even a more couple of percent of energy usage, which in the grand scheme of things, because buildings are 40% of the CO2 problem, result in massive savings in the system. So that's, just another example.
Yeah. No, fascinating. I have solar panels on my roof here at home. And one of the things I did recently was I installed the solar panels in 2018. So I went to my portal for my solar panels. I have an online portal where I can download the data. Downloaded the data for the last 6 years of solar production. Came out in a CSV file. I gave it to ChatGPT. I had it analyze that data. And one of the questions I was curious about was, has there been a reduction in the efficiency of the panels over the last 6 years? Because they're on the roof. They're not easy to clean. Birds sit on top of them all day and soil them, to your point. So I wanted to know, should I go up on the roof? Should I scrub them to make sure they're clean? And turned out no. It turned out over the last 6 years, month on month on month on month, the output hasn't dropped significantly. Probably wouldn't hurt if I did clean them, but it's not, they haven't lost, they haven't lost any noticeable output. So AI has been able to, just in this very simple analysis, tell me I'm fine. I can imagine in a far more complex situation, the outputs are going to be far more nuanced, but also far more helpful.
Wonderful example. So now in the commercial and industrial world, this would be the sort of the jump from preventive maintenance to predictive maintenance.
Right.
And then the next step would be prescriptive maintenance, intelligence-based prescriptive maintenance. But just that jump, do I need to send out that maintenance crew twice a year to sort of clean the solar panels on 1,000 buildings? Does that really help? Maybe not, right? If I had that data, right? And that's exactly this is the kind of use cases that we're running. This makes the whole system more efficient because that crew obviously comes with cars, goes on the building, spends time and the like. So, great example, right? The movement from, this is the mega trend, right? To go from purely preventive, schedule-based preventive, onto predictions and then autonomous operations, right? Of a building, or a electrical depot with electric trucks and the like.
Sure. The monitor report, the infrastructure transition monitor report that you talked about earlier, it also points out various challenges and divides in the path to net zero. So, in your view, what are the most significant barriers and how can we overcome them?
So there is no silver bullet, obviously. I think there is big stones, there's clusters, and the clusters, they are structured around these 5 major areas of emissions. Buildings follow a specific logic and need and requirement of decarbonization, which is very different from electrifying our vehicle fleets. So you have to argue by domain. And then there's overarching trends and discussions. An example would be hydrogen. What is the role of hydrogen? Which use cases make sense in an industrial setting, in an e-mobility setting? What is the role in the production of energy? Power to X kind of use cases, sector coupling use cases using hydrogen, for example. That's an overarching question. So there's a few fundamental technologies, and then let's not talk about nuclear fusion, right? If we ever get there, and that is, obviously another, total game changer if we ever get there. So a few big overarching areas and stones that we just need to continue to push and invest to clarify where exactly does hydrogen have the economics and the use case to help us accelerating the path to net zero and reversing climate change, for example, right? But otherwise, you are very domain specific. We could talk about agriculture, as an example. That's a completely different ballgame, right? Of how to, make sure that plants sequester more carbon than they emit, and the like. We could talk about that as well, right? But that's a completely different, discussion that needs to happen there, compared to process industries and chemical.
Yep. We are coming towards the end of the podcast now, Thomas. Is there any question that I didn't ask that you wish I did, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
I think not so much an aspect you didn't ask, but I think maybe a remark, or sort of a comment I'd like to make, which is often in these kind of discussions on sustainability and decarbonization, there is an assumption that we're not going to get there as humanity.
Right.
It's the underlying assumption. Right? When I talk to my friends, on panels and professional settings and whatever it is, the majority of people, I think is fair to say, think that humans are not able to organize themselves in such big systems, which, we're talking about a global system here, right? to take the right decisions together across political, ideological, geographical boundaries to get there fast enough. And I absolutely want to break that perception. Because yes, we will be too late. Yes, we will see catastrophic impacts of climate change, but ultimately we'll get there. And so maybe that's, now we're on a philosophical level, but we're also on a level of concrete behavior change of all of us every single day. Because if you decide for an electric vehicle as your next vehicle, even if it, charging still don't works 100% and it's a little more expensive and it's a little more cumbersome and all that, right?
Mm-hmm.
If you do that, obviously your neighbors take notice.
Yeah.
And obviously you talk to your friends about it. So you have a multiplier effect of maybe 100 people, at least. So just think about that. If we systematically configure our Uber or whoever ride-sharing apps with the now available option that I always prefer low carbon or electric vehicles, well, then guess what's happening? More drivers are going to buy electric vehicles. So, I just want to put in I want to suggest a positive, fundamentally positive can-do attitude in reversing climate change and to actually get there as humanity if we all multiply the efforts. That's really I think the spirit I'd like to instill.
Yeah, no, it's a good point. And I'm actually on my third EV at the moment. And my car before that was a hybrid, a Prius. So I'm doing my bit. And in fact, because I've got the solar panels, it means very often I'm driving for free and gratis because I've charged the car. I tend to plug it in more on sunny days. And so it charges directly from the solar panels. So driving on sunshine, it's great. It's great.
Can't wait for the option that airlines are going to put out pretty soon. That obviously, per definition in my traveler profile, I prefer biofuel-based, decarbonized fuel trips with airlines, just as I just did in my Uber app. So,
nice.
We got to go step by step, I think.
Yeah. Fantastic. Thomas, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
So that we mentioned the infrastructure monitor that we put out once a year. It's very comprehensive. It has a lot of material, a lot of data points, further reading. So it's a real ecosystem sort of publication. I recommend that, and I would recommend to just put it in the link and publish that. Look at my LinkedIn. We're regularly publishing, together with all of the leadership team of Siemens, updates, on that whole end-to-end question. And yeah, that's pretty much it.
Fantastic. Okay, great. Super. I'll put those links in the show notes. Thank you, Thomas. It's been really fascinating. Thanks a million for coming on the podcast today.
Thank you, Tom. Appreciate it.